All right, so 2.3 is conditionals and biconditionals. So again, a lot of today is taking, just paying attention and then writing a few things in. So first up, a conditional statement says, if P then Q. This form is denoted as P with an arrow Q. So we could say P implies Q here, but most of the time we're going to read it as if P then Q. Okay, so P is your hypothesis. So P, hypothesis, and Q is the conclusion. So for example, if a man is unsaved, then he will spend eternity in hell. So what is the P here? So in that one, in that example, what part is the P? If the man. Okay, so man is unsaved would be our P statement, right? If, and then P, so man is unsaved. Q, the conclusion will be what part of it? Go ahead, Justice, you got it. The last part is what? Okay, we'll spend eternity in hell. That's our Q statement, our conclusion. Okay, if he's unsaved, a man is unsaved, then he will spend eternity in hell. Good. All right. So we're going to take, in example 1, we're going to take some statements and we're going to write them in the if-then form. So it's going to help us to know what the P and the Q are. So if the, let's see, for A, there are no clouds in the sky, so it's not raining. So what's the hypothesis? So, okay, not raining is actually our hypothesis. So we're going to say if it's not raining, then what's our conclusion? There are no clouds in the sky. That is our Q. So good. So if it's not raining, then there are no clouds in the sky. So if it is not raining, then there are no clouds in the sky. Or, let's see. How do you think, no. How do you think that sounds? If it's not raining, then there are no clouds in the sky. Is that true? Can it be cloudy and not be raining?
Yeah, but if it's not raining, there will be no clouds in the sky. Oh, wait, no. When it's not raining? If it's not raining, what dark clouds?
No, we can't change it to dark clouds. No, we don't get to do that. It's just if and then. So we picked the wrong hypothesis. I know, right?
Did that on purpose?
I did.
I know it's on 10.
I'm sorry.
Woman.
Because we make mistakes. Math is messy, folks. It's messy. It's okay. It really is, I promise. So it really is as simple as saying if there are no clouds in the sky. That's an E. If there are no clouds in the sky, then it's not raining. I know I am. I'm very mean. I'm sorry. So then let's look at B. School will be canceled when a blizzard hits. Okay, so if we change it to when a blizzard hits, school will be canceled, that's more of the if-then style. So let's put it in the if-then. If a blizzard hits, so if a blizzard hits, then school will be canceled. And you can go ahead and write this because it's, and make your notes pretty. So if a blizzard hits, then school will be canceled. Are we good with that as an if-then statement?
Is what school will be canceled, is that the conclusion?
Uh-huh. School will be canceled is the conclusion. Good. Now C, we actually do get to add a few things too to make it make sense. A triangle has 3 sides. How do we put that into an if-then statement?
If a shape has 3 sides, then it's a triangle.
Excellent. If a shape has 3 sides, then it's a triangle. Or you could have put polygon if a polygon has 3 sides. So if a shape has 3 sides, then it's a triangle. Very nice. That was good. Nice. So these are, remember, are called what kind of statements? No. Okay, an if then is a conditional statement. Okay. We can say it's an if then, but we need to work on using that conditional term, like using that geometric terminology. Okay, so these are some excellent conditional statements. I like it. If it's an if then it's a conditional statement. Very nice. Way to use the structure. Okay, so then I'm going to slide this up just a little bit maybe. The only way a conditional can be false, okay, is if the hypothesis is true and the conclusion is false. Okay, so let's see. So conditionals with a false hypothesis are always true because nothing is implied when the hypothesis is not met. Okay.
So you can say if a shape has 3 sides, then it's an octagon, and technically it's true.
No, but the hypothesis is true. If a shape has 3 sides, like you could say, if a dog is purple, there are no purple dogs. Like if a dog is purple, then it's a Dalmatian. There are no purple dogs. The hypothesis is false. Yes.
So why would you say if a dog's purple? Because that's not true.
Right.
The hypothesis can be true or false. It can be true or false?
The hypothesis can be true or false. Yes.
But
The conclusion can only be true. Okay, so let's look at it. I know it's really weird. It's totally random, and it's kind of how it feels. So let's break that down again. The only way a conditional can be false is if the hypothesis is true and the conclusion is false. So then we go down here. Look at this next part. Conditionals with a false hypothesis. So if I have a false hypothesis, those are always true because nothing is implied when the hypothesis is not met. We're going to look at an example of that in example 2 to help it make some more sense. Because anything that can't be shown to be false is considered true. If we can't prove it false, then we're considering it true. I know that it's totally weird though. And like when people say, well, when pigs fly, or if pigs fly. Well, pigs don't fly, so the statement they're saying is true.
I can throw that bacon pretty far.
Okay, so let's look. We've got this truth table set up over here for our p values and our q values that we did last week. So if we're looking, this is a conditional. If p, then q. It said we have to have, right, the only way a conditional can be false is if the hypothesis is true and the conclusion is false. So there's only one time in this truth table that this is false. The second time, right? When our hypothesis is true, then that's the only time it's false. Otherwise,
What about the false?
no, because again, if it has a false hypothesis, they're always true. So anytime it has a false hypothesis, it's still considered true.
Basically, it can be all the way false, it's still true.
It could be all the, yeah, it could be 100% false when it's still true.
That's true.
I know. I don't disagree with you. I'm telling, like,
I'm sorry,
but let's apply it and see if we can't make it make more sense. Okay, because the next one I promise does make more sense. Example 2. So let's take this idea down to example 2, and let me see if I can get the sun from the blinds off of this. Okay, there we go. So example 2. Coach Jones promised his players, if you win the championship game, then I will buy you a steak dinner. Okay, so determine the truth value of this statement in each case. Okay, so here's the thing. And I don't know that this is really going to prove our point with the other one. It's not, but that's okay. I thought it was going to. So disregard what I said about it kind of proving the point, and I'll come up with a better example for the conditionals. Okay, but let's look at these then. So in example A, Coach bought steak dinner after they won the championship. Let's see if I can get a little bit better.
So is that
A little clearer.
Is this like saying true or false or what?
Okay, so let's look. Coach Jones promised his players. So here's this conditional statement. If you win the championship game, okay, so winning the championship game is our P, then I will buy you a steak dinner. So there's our Q, our conclusion. Okay, so determine the truth value of the statement in each case. So we want to know if it's true or false of the statement. Coach bought a steak dinner after they won the championship. Okay, so we can think, did they, was P met?
Yes.
Did they win the championship game?
Yes.
Well, it says after they won. So did they win the championship game?
Yes.
Why are you shaking your head no, Justice?
She's messing with you. Yes.
Okay, so P is met. So that's good. Okay, was the conclusion, we're going to say the conclusion, or Q, satisfied? So the conclusion says, I will buy you a steak dinner. Did Coach buy the steak dinner?
Yeah.
Yes. So would this be true or false? True. Okay, and we have to go through this process with each and every one. So B, Coach didn't buy dinner after they won the championship. Well, was P met?
No.
After they won? They won the championship dinner. Yes, they won. So was Q satisfied?
No.
So this is a no. I'm going to put my question mark in there. So no. So this is false. Like he didn't stick to his word. Or she, I guess Coach Jones. We don't know who that is. That'd be awesome. Okay. So far, are we okay with breaking down, like, is P met, our hypothesis? Okay, so let's look at C. Coach bought dinner after they lost the championship. So was P met? No, this time, right? They lost the championship dinner. Was Q satisfied? So in this one, if they don't meet Q, then this one you can just disregard it, actually. Because he said, like, the P was... Right, in this case, he's just a very nice guy. So Q satisfied, we just kind of disregard this at this point because P wasn't satisfied. But is this a true statement? He said, if you win the championship game, then I will buy steak dinner. Did they win? No. So did he have to buy the steak dinner? No. So is this true or false? No, it's true.
It's true because the P... If the P's false, it's still true. And this is why nobody likes geometry.
Right. Okay, so we didn't meet P, like, because P P didn't come true.
So just
Maybe it's how we should talk about it. Is P didn't...
Is if P comes true, then you look at Q. If P doesn't come true, then it's already a disregard and it's true.
Okay, so let's look at D. Coach didn't buy dinner after they lost the championship game. So let's think again. Is P met?
Yes.
No, they lost the game. So we can stop there because the P is false at this point. So the statement itself is true. Yeah. Because we didn't meet the hypothesis. The hypothesis did not come true. So I was right. It does reflect what we were talking about above. Just like we're given the hypothesis, but the hypothesis is either met and it's true, or it's not met and it's false. Lucas, are you okay? You look like you're off in La La Land. You're good. Okay. After I spilled water on him? Oh, I was like, I didn't spill water on him. Okay. Then let's go to the other side. Okay, and let's look at some related conditionals. Let's not say we did, right? Except we can. It's not how it works. All right, so related conditionals can be formed from any conditional. Okay, they can be formed from any conditional. So there's, I've kind of got some shorthand out there on the side too to help us. So see if I can balance that all in there. For some reason, my screen here. There we go. That's a little better. Okay, so the first one is the converse of a conditional. The converse. Okay, it's like a shoe. Yeah. So it's the reverse hypothesis and conclusion. So if we started with P, if P, then Q, now we're going to say, well, if Q, then P. So the converse, and so that's what that says here. If Q, then P. So in the first one, we said if a man is unsaved, then he will spend eternity in hell. Now we're just going to change that and say, if a man spends an eternity in hell, then the man is unsaved. Does that make sense? Okay, so the converse is just changing the order. The inverse of a conditional, we negate the hypothesis and the conclusion. So that is, if not P, then not Q, is what is out here, right? That's what these wavy lines mean. It's called a tilde in Spanish. Correct. Yeah, that's okay. That's okay. If you do not, that's a good one. If you don't do drugs, then you do not get high. That would be an okay one to use. All right? Because then the original conditional would be if you do drugs, then you get high. It depends on the statement. Which ones are going to make sense? You could do that one. Yeah, because the conditional would be if you work out, then you get muscles. So we could say if you do not work out, then you do not get muscles. Right. Whereas like in the converse, we would say if you don't have, or if you, let's see, we said if you work out, you get muscles. The converse would say if you get muscles, then you work out. Does that make sense? So it's just the way we're ordering the phrases in the statement. Okay, good. All right, last one is a contrapositive. Okay, so this one is we're negating and reversing the hypothesis and the conclusion. So we're doing the converse and the inverse together. Yes. So it's going to say if not Q, the conclusion comes first, just like in the converse, then not P. So yeah, the contrapositive is taking the converse and the inverse and putting them together. Well, it is kind of a difficult word. But you can think it's contrapositive. It's got like two parts. So you're doing two pieces together. Okay, so next up, The converse and inverse don't always have the same truth value as the original conditional. Yeah, right? They don't always. So that's important. They don't always have that same truth value.
So it could be true, but if you swap it around and mix it up a little bit, it could be false.
Yes. Now, the last one is actually really important because your original conditional and its contrapositive are logically equivalent. So the contrapositive and the original conditional are logically equivalent. So that's helpful. Example 3, we get to put it into practice and try some out. So this is the most work you get to do in example 3 today. Woohoo, right? Well, you do have homework, but I'm saying like in the notes. Okay, so in example 3, it says write the converse, inverse, and contrapositive of the following conditional. So if the measure of an angle is 135 degrees, then the angle is obtuse. Then determine whether each is true or false. So first off, let's identify our hypothesis and our conclusion so we can get these right. So if the measure of an angle is 135 degrees, what is that? Hypothesis P or conclusion Q? Hypothesis, yeah, because it's an if, right? Then the angle is obtuse. That's our Q statement. All right, so first up, let's do the converse. Okay, let's look at the abbreviation. Converse was if what? Q? Then, okay, so I'm just going to write this down here so we can remember. So if Q, then P. And so what did you say? If the angle is obtuse? Okay, so we're going to say if an angle is obtuse, then and we can change. Okay, so we can change the phrasing a little bit, but keep the idea. So if an angle is obtuse, then the measure, good, of the angle. Okay, then the measure of the angle is 135 degrees. Excellent! That is the converse. So now we're supposed to decide if that's true or false. Lucas, is that true or false? If an angle is obtuse, then the measure of the angle is 135 degrees. Does every obtuse angle measure 135 degrees? No. So tell me again, is it true or false? It is false. Okay, because we know obtuse angles, that's supposed to be a V, are greater than 90 degrees and less than 180 degrees, right, to be obtuse. So they could be in any range there. Okay, next up is the inverse. Am I going too quickly? Or are we okay? Okay, I heard from one person that we're fine. Justice, how about you? Okay. What is the inverse? What's the shorthand for the inverse? Look back at your notes. It was. Oh, it says, that's a good call. We know that obtuse, I wrote it in there. I said obtuse is like x is greater than 90 degrees, right? Or x is less than 180 degrees. Is what it said, but I'll rewrite it. Okay, so what's the shorthand for inverse? Remember for converse, it was if P, then Q, or if Q, then P. What is it for? Okay, so if not P, then not Q. Good. So, Justice, what's the, start this one off for me. If We just need to insert not somewhere in there. We're keeping... Perfect. If the measure of an angle is not 135 degrees. Okay, Lucas, give me the then. So we just need to insert not in the Q statement. Then the angle is not obtuse. Good. Perfect. So if the measure of an angle is not 135 degrees, then the angle is not obtuse. How about its truth value? Or what if it's true or false? So if the measure of an angle is not 135 degrees, then the angle is not obtuse. Can we have an obtuse angle that's not 135 degrees? Yes. So is this true or false? False. Absolutely. Now, if we were talking about right angles and 90 degrees, then this would be true. But we're not talking about those. All right, and the last one is the contrapositive. What's the shorthand for the contrapositive? Remember, contrapositive is like two parts. Good. It's the not Q, then not P. Okay, so Tori, can you start it for us? The if. So we could take our inverse and just switch their order even. Okay, so if the angle is not obtuse, then the angle, what'd you say? Okay, then the measure of the angle is not 135 degrees. Fantastic. Okay, how about this one's true or false? What's its value here? If the angle is not obtuse, then the measure of the angle is not 135 degrees. True? Why do you say true, Justice? No, tell me why you said true. So if the angle is not obtuse, so it's acute or right, then the measure of the angle is not 135 degrees. Well, if it's acute, can it be 135 degrees? No. If it's right, can it be 135 degrees? Nope. So this one is?
No, it's true.
It's true. Like we just logically explained why it's true. Yeah.
No, because it can be like 134 and that's still obtuse.
But it's saying if the angle is not obtuse, then the angle measure of the angle is not 135 degrees, which is true. If it's not obtuse, it can't be 135 degrees.
I knew I was smart.
You are smart. Yes. Let's say, and you, like, because you all are smart. I doubt that we'll finish it. False. There's always homework.
That's true. No, it should be if we don't finish it and there's no homework.
No. You just have less homework, but not no homework.
How would you do less?
Okay. So let's look at the contrapositive rule then. Okay, so this is one of our theorems, which is why it has a T there. right? Anytime it has a T in it, it is a theorem for us. And then we've talked before, but this tells us it's found in chapter 2, section 3, and it's the first one that comes up in that section, which hasn't seemed important yet. But in this chapter, you're going to start getting 4 and 5 theorems per section. So it does start to be helpful to know where to look. But so the contrapositive rule is a conditional is equivalent to its contrapositive, which we already talked about previously, that they were equivalent statements. But this is the theorem that you can go back and reference during a proof as well to use. All right, then I think we will stop there today, which is going to change our homework assignment. Because right now it's on page 68. And let's do one through 15 odd. So let's see. There's 1 through 15. 15, not 5. 1 through 15 odd. And okay, let's go ahead and do some of the review, the cumulative, oh my goodness, review. So 54 to 62, even. Okay, and that is that page 68, right, is where it starts? Okay, so let's modify that homework to this amount. And then tomorrow's lesson will be 2.5, because I already have it, or not 2.5, 2.4, because I already have it recorded.